Good day to all of you. Today we shall discuss on Model Question Paper 1 with effect from 2023-24 CBCS scheme, 3rd semester BE degree examination. The subject data structures and applications with subject code BCS304. In that question number 1c, write a program in C to implement push, pop and display operations for stacks using arrays. It carries 7 marks. So if 5 memory locations, consecutive memory locations are reserved, so it is a array data structure. What is the name of this array? Let us give it as stack. So we can give any name, A, B, C, then A array, B array or C array. Now we are giving the name stack. How many memory locations are there? 5 memory locations are there. They are in consecutive manner. Means if address of this is 1000, 1001, 2, 3, 4. So this whole block forms one data structure. A data structure having a set of consecutive memory locations, that is called as array. Okay, its name we have given stack here. Then if I want to access this memory location, so each location is identified by the index. This is index 0, this is index 1, here 2, here 3, here 4, right? So an array of size 5 memory locations will be there. The index vary from 0 to 4. Totally 5 memory locations which can be identified by the index 0, 1, 2, 3 till 4 it is. If 10 memory locations, the index varies from 0 to 9. So if I want to store 100 in first location of this array, I have to take by its name. Name is stack here. Then its index, that equal to 100 semicolon. This is a C statement. If I give in the C program, then it goes to stack array. In that 0th position, in that content, it is made 100. So this is how by index values any location in array by its name with its index, it can be accessed. If I write stack of 4 equal to stack of 0 semicolon. This C statement, when we execute, what happens? It goes to stack array, that is this one, index position, that memory location here, equal to, it is assigned which value? Stack. It goes to again stack array. In 0 indexed memory location, what is there? That is 100. So equal to, assign means this 100 will be copied into this location. Okay. So this is how an array can be created by a name and having some size. Then each location can be accessed by its name and index. That is what is all about array data structure. So this only is going to be used as stack. The property being the stack can be added only at the top, can be removed an element from only at the top. That is what is stack. It's a LIFO data structure, last in first out or first in last out. Okay, so that we shall see in detail next. So next we are going to take a set of memory locations, a block of consecutive memory locations. So how many memory locations? 100. So this is first, second, third and so on till the last one. Next, what is the index of first one? 0. Second one 1. Third one 2. Fourth one 3. Fifth one 4. So these are the index of memory locations in that block of consecutive memory locations, which is array. What is the last memory location index? 99. Size of that array is 100. Array, we are going to call it as a stack. So this array we are going to call as stack. What is this location? Stack of 0. This one stack of 1. This one stack of 99. But we are going to declare another variable n and read it as 5. So from index 0 to 4 we are going to consider, and that will be our defined stack. So reserved is 100, but out of that, for our work now using only 5 memory locations. Starting index is 0, the last is 4. Okay, this is our stack now, which we are going to use. So one more variable we are going to declare, that is top. Now top is made to store index. If it is 0, it points to this memory location. If it is 4, it points to this memory location. Okay, when top is 4, our stack size defined is 5. Now if you try to add an element through push operation, it will increment the top, then it will try to add here, but that is not there in our stack. It is defined to be only of size 5. So then stack full, this push operation cannot be done, then stack full message we will display. If top is -1, then no stack only, though defined 5 memory locations, nothing is stored, stack is empty. So that we have to display when top is -1. Okay. So if top is -1, stack is empty, we cannot do pop operation for removing an element because no element only in the stack. This we cannot do. When top is 4, this one, so stack is full, hence we cannot do push operation and try to add any element because there is no space. That is another point. Next one more variable we are taking, that is choice. If it is 1, push operation is done by calling push function. If it is 2, pop operation is done by calling pop function, that is to delete an element from the stack. When choice is 1, through push, adding an element to the stack. When choice is 2, through pop operation, deleting an element from the stack. If choice is 3, then display operation, that is displaying one by one this content of memory locations in the stack is done. Okay. So now this implementation as per choice, calling that function, for adding push function, for deleting pop function, for displaying display function, that is implemented using switch case construct of the C language. Okay, that is another point. So these are the some of the issues and the plan which is followed in implementing a stack using array. The implementation is done using language C. Okay. So what is stack? Stack is a linear data structure that follows LIFO, last in first out, or first in last out principle. The linear data structure in the sense memory locations will be in the sequential order. Okay. So with the stack we can do inserting an element into the stack at the top index position in the stack using push operation, delete an element from the stack from the top position index position memory location in the stack through pop operation. Then stack can be implemented using two types of data structure, one with array, another one with linked list. And in our discussion we are seeing through how a stack can be implemented and operated using array data structure. This figure shows Stack data structure. So how many memory locations are there? 5. What is the index of this? 0. This is 1. Last one 4. Top is used to store the value of index. So push operation is used to add an element at the top position in the stack. Pop operation is used to remove an element from the stack at the top index position in the stack. So implementing a stack using array. So we have to define the maximum size of the stack. Declare an array of the desired data type. So data type means we may declare it to store int, float. But out of maximum size, how many we are going to utilize, that we have to declare. Then declare top variable and initialize with -1. Okay. So implement push function for adding an element to the stack. Then implement pop function which removes an element from the stack from top position. Implement the display function which displays the elements of the stack. So these we are going to do. So stack implementation using C language. This is preprocessor directive, that is stdio.h. H indicates header file that is included in our program now. So with this some of the functions like printf, scanf that we can use to display the message on the monitor, to read any data from the console, that is whatever we type on the monitor that we can read into the memory what we are using in the program. So next, these are global declarations. Whatever variables, choice is a variable, n, top, then stack of maximum size which is an array of maximum size 100. So these are the variables. Then these are the functions, push, pop, display. All these are made global, means in any part of the program they are accessible. Their scope is they can be accessed from any part of the program. Okay. So X is used to read the new element which is going to be added into the stack at top position. Then I is taken for loop. When all the 5 elements are to be displayed one by one. So I starting from 4, then 3, 2, 1 till 0 index position in the stack memory, one by one elements are accessed and they are displayed. So I is used as iterator, or for loop statement it is used. So the start of main program execution starts from here. Top is made -1. So it is assigned value -1 because stack at starting it is empty. Scanf, out of 100 sized stack, how much size stack we are going to use. If we give 5, we are going to use from index position 0 to 4. Our stack is going to be of size 5 if we give n as 5. Next, this message we are giving, displaying on the monitor, so that the user is going to enter 1 for push, 2 for pop, 3 for display, and 1 extra we are taking here for 4 for exit operation. So the implementation, it starts from do while statement. So this is do, this is the start of that looping statement. What must be done first? The choice must be read. So that is read in a choice variable. Scanf will read. This is the display message. Enter your choice. Then the user will enter either 1, 2 or 3 depending on his requirement. Whether he wants to add an element or remove an element or display the elements from the stack. So when choice is read, switch choice means depending on the value of choice. If it is 1, it will call push operation. If this is 2, it will call, it goes to case 2 block, it will call a pop function. If it is 3, it will go to case 3 block and it will call a display function for displaying elements. If it is 4, then it will go to case block 4, their exit point means it will come out of switch case statement. So if any other value is given, there must be some proper message. User should give only 1, 2, 3 or 4, that message is printed. That is default block of switch case construct. So how many conditions are here? 1, 2, 3, 4. Fifth one is default. Those are checked and accordingly corresponding action is done. So here do while loop is over. While choice is not equal to 4, this whole thing must be executed as calling the corresponding function. In those function, what is there? We'll see next. Here return 0 means int main. From there program execution had started. This is end of program. Okay. This 0 will be returned to OS because int main, that main function was returning int type data to operating system. Hence 0 is returned to OS. This is the end of main program. In the next part, what we have to see, how push is implemented, pop, display and exit are implemented. That we shall see next. So next, push operation, which is called to add an element to the stack at index position top in that memory location in the stack. So algorithm is, if top is greater than or equal to n minus 1, means the index of top position will be 4 if 5 memory locations are there in the stack. So then the stack is full. Okay. Otherwise top must be incremented and stack top must be given with the data. So here otherwise is there, else, otherwise. So that in the coding here, this is a push function which is implemented in the C. This is its comment. It is explaining what next is doing. So its return type is void. So this push function doesn't return anything. Empty brackets indicate here it is accepting no parameters. So this is begin of push function. So if top index is greater than or equal to n minus 1, then stack is overflow is printed. Otherwise enter value to be pushed. So if we 10, give 10, that is inserted. Here we are giving 20, 30 values. So they are read in X variable. This scanf means read statement. Whatever we type on the console, that suppose if we type 20 there, so that is read here into X variable. So then top is incremented by 1. So if it is 0, it is made 1. If it is minus 1, it is made 0. Okay. Stack at the top index position memory location, X value is added. So that is implementation of push operation in C. So top would be minus 1 first. When one value say 10 is given, that is read in X variable. So top is incremented by 1, so it is made 0. In that stack of top, stack of 0, in that memory location 10 is assigned, means it is copied. So next time if 20 is given, that 20 is read in X, then top is incremented from 0 to 1, that is this statement, stack of 1. So in that position 20 is added and this continues. Okay, and that is what is push operation, which is going to add the given element. So next pop operation, which is going to remove an element from the stack at the top indexed position in that memory location in the stack. So this is the algorithm. If top is less than or equal to minus 1, stack is empty. That message must be printed. Otherwise value is taken from stack top. So that is copied in value variable. Okay. So top is decremented by 1, right? So this can be taken in value variable or directly it can be printed. So that is directly printed here. If for any usage it is required, that can be taken. But in the program that is not taken here, just it is printed. And next top is decremented so that the stack size is reduced and the top position in that what value was there in that memory location in the stack, that is not considered now. Means here If top is less than or equal to -1, stack underflow or stack is empty is printed. Otherwise, there are some elements. Suppose this element that is uh, that is at stack top, that is printed. Then top is reduced by 1, means the top will be pointed to this. So now our stack under consideration will be only 4 memory location. So fifth is out of consideration, means that element is removed. That is what is the meaning of pop operation. Okay. Next, display operation. So the algorithm is, if top is greater than or equal to 0, means that this position. If it is here, stack top is -1, stack is empty, but at least the index must be 0. So if it is greater than or equal to 0, I equal to top to greater than or equal to 0, that is from 4 3 2 1 0 if stack is full. Otherwise, till where it is full, 4 3 2 1, if 4 elements are there. So from top position whatever are there, those elements are printed from stack, that is stack of I. Stack of 4, stack of 3, stack of 2, stack of 1, stack of 0, means one by one these elements will be printed. Okay. Otherwise stack is empty. Otherwise stack is empty means top is neither greater than 0 nor equal to 0, means it will be -1. Right? So if it is -1 empty, so from where it is full, that is top here, it is 3 2 1 0 till index becomes from 3 to 0, all the elements one by one will be displayed. That is what this display function does. So here display function is called, if top is greater than or equal to 0, then elements are there. So the elements in stack are, that heading is printed from top position till 0, one by one the element from stack are printed each time, that is stack of I. First stack of top, if top is 4, stack of 4, then I is decremented, stack of 3, again I is decremented, stack of 2, till I becomes 0. So from 4 3 2 1 0, all the elements will be printed. So next choice is asked here. Otherwise stack is empty. Otherwise means that this top is neither greater than 0 or equal to 0, means it will be minus only, indicating stack is empty. Then when empty, no elements can be printed. So it is all about display operation, right? So this is one sample output that we can see. Only for push operation we have taken here. Likewise, for any kind of operation we can do. So enter the size. Stack maximum available is 100. So the size defined n equal to 10 we are giving. So this heading is written 1 for push, 2 for pop, 3 for display, 1 extra we are doing, 4 for exit. So enter the choice is written, user is giving 1. It is asking value, then 12 value is given. This will be added to stack. Similarly, next time 24, next time 98. Like this, by giving choice 1 it is done. Likewise, when top is -1 during starting, when we have not added any value, then if we try to give choice 2 and try to remove an element from stack, then stack empty message will be printed when we execute this program. Okay. Suppose if you give choice 6, then not a valid choice, enter choice 1 2 3 4, that will be printed. 1 for push, 2 for pop, 3 for display here, 4 extra we are taking, that is for exit operation. The control will come out of switch case, then after that exit 0 is there in the main program, it will exit from the program. It was all about the C implementation for the stack using arrays. So next we shall see what are the pros and cons of stack implementation using array. Pros means advantages, cons means disadvantages. Stacks doesn't need extra memory when implemented using array. They do not need extra memory to store pointers like how they are required in linked list implementation of stack. So, as a last point, we shall see to the pros and cons of stack implementation using array. Pros means advantages, cons means disadvantages. On advantages side, the implementation of stack using array doesn't require extra memory because we don't store any pointers here. That is what is required in stack implementation using linked list. Their extra memory is needed to store pointers. That is not needed here. Next, it is more efficient in terms of time compared to stack implementation using linked list. Disadvantages: the size of stack is fixed. Once if we define or declare it as 5, we cannot add a sixth element, that is fixed. So it cannot increase or decrease stack implementation using an array. Then insertion and deletion in an array are quite difficult because as it stores the elements in consecutive memory locations. In sequential manner only we have to move through and reach the required index position of the memory location. Okay. So that is what is all about implementation of stack using arrays. That implementation in C language for push function, pop and display operations. That completes the whole discussion. I hope you understood. Thank you.